calls for this kind of thing, people saying we need it. There's an executive order from December of 2020 that essentially says that the federal government should ensure that all of the AI that it uses is trustworthy. But I think that often comes with questions about what on earth this is supposed to mean. And I think there's a very common view which starts from the observation that AI models are at root, in many cases, we could think of them as just math. They're just the ones and zeros of the code that implements the particular AI model. So if, to use a personal example, I've got an AI model that can predict blood pressure crash during normal surgeries. This is a joint project with folks at the University of Pittsburgh Medical Center. Then you might say, well, what do we mean beneficial AI? The AI is just a bunch of code. And if the AI is just a bunch of code, then ethics, values, notions of being beneficial are going to matter only when we go to use that math. That is, I think it's very common for people to think of AI as just a tool, that its ethical questions, value questions arise only when we are in the position of starting to use these tools, not when we think about the construction of the tools in the first place. But one of the things that I think has really emerged over the last 5 to 7 years is a pretty strong consensus that AI is really much more than math alone, although that's what may happen in a lot of the classes, for example, in the data science major at UCSD. A lot of the classes are focused on the mathematics, but in fact, when we think about AI, we need to think about everything from the identification of a problem, the collection of the data, the generation of the model, the refinement of a model, the deployment of the system out in the world, the ways in which the system that is deployed is actually used by people, and so on. And so when we think about values and ethics, when we think about the kinds of things that might explain why we would say something is beneficial, we really need to make sure to think much beyond just the models themselves. We need to think about the entire life cycle of an AI project, all of the choices that go into it along the way. One of the standard exercises I do with students is we'll pick an example of something that people are actively doing right now in terms of building AI. Say we want to have something that will predict student mental health. Very common. There are discussions happening at UCSD right now about having an AI system that can help to predict potentially acute mental health crisis amongst students. This is important in terms of ensuring that we're able to, of course, provide adequate support to the student population. And we go through all of the choices that we would have to make in order to create and responsibly use such a system. And when we look at the list of choices that would have to be made, all the decisions that have to happen, one of the things that I think all the students quickly realize is that there are only about 2 of those steps that are where the mathematics compels anything at all. Most of the steps involve choices that are sociological or legal or ethical. They're about the values that we have and the things that we want to advance through the AI system, as opposed to the AI just being a bunch of math and ethics don't ever enter into the game. And so when we think about beneficial AI, what we need to recognize is that all AI systems implement or advance certain values and not others. And so when we think about beneficial, it's not so much, is this AI beneficial? AI systems are pretty much always beneficial for somebody. What we often mean is we're trying to figure out how do we have systems that are beneficial for certain groups, or broadly beneficial, or beneficial for more than just a company. And so we have to ask the question, beneficial for whom? For whom are we trying to have a system that it provides certain kinds of benefits? And one of the challenges that immediately arises here is to turn philosophical for a moment. We distinguish between value pluralism and value conflicts. The idea of value pluralism is pretty simple. It's the idea that different people have different values. I value dogs differently than, say, Barbara does, right? I have no idea if she's a dog lover or a dog hater, but the odds are pretty good that we don't exactly value dogs the same, right? But the fact that we have value pluralism, that she has one set of values and I have a different set, and these are different sets of values, doesn't necessarily mean that we have value conflicts. because presumably, even if, she turns out to be somebody who's not a fan of dogs, we can still agree that we ought not ban dogs from the United States and say dogs are not allowed anywhere in the US. Or we ought not, if we wanted to be even more, we ought not, necessarily do torture of dogs or something like this. Now, obviously, we all agree that would be a terrible thing to do, despite the value pluralism, right? So we can disagree in some ways, but yet we can all agree in terms of not having a value conflict. Okay, so a value conflict arises when there's no way to satisfy multiple people's values. So a value conflict would be the kind of thing where, I, as a bank, am trying to make a lot of money. Other people as loan applicants are trying to get access to financial resources. We value different things to different amounts. And a value conflict would be if there's no way to have, say, an AI loan approval system that's able to satisfy both of us equally. Or to use another example, if we think about self-driving cars, these are very much in the news right now, in large part because of the approval for them to function as self-driving, no human driver taxis in San Francisco right now, the decision that was made here in California. Well, you can have a self-driving car that always follows the law. You can have a self-driving car that always minimizes the probability of an accident. You, in most real-world situations, cannot have a car that does both, for the simple reason that to minimize the probability of an accident, you want to drive slightly slower than prevailing traffic. If you've ever, think about driving on the 5 when it's not the middle of rush hour, people are driving a whole lot faster than the speed limit. So the self-driving car has to decide, does it follow the law or does it drive slightly slower than the prevailing speed of traffic? Now, that's a case where the value pluralism may result in a value conflict, because I might say, no, the car should always minimize the chance of an accident. Barbara, you're getting to be my example today. Barbara might say, no, it should always follow the law, in which case there's no way to build a car that satisfies both of us at the same time. Now, you might have a car that we can tune, so we can each have it be the way that we want it to be, but we wouldn't be able to have a car that satisfies everybody.
Excuse me, could everyone please put their Zooms on mute during this speaker's lecture? Thank you so much.
So what we worry about much more when we're building these systems is we don't just worry about, in some sense, value pluralism is ubiquitous. That's not the thing that's worrisome. The problem is value conflicts, because now we do have to take seriously this question of beneficial for whom. Because if there's a value conflict, then there's no way to satisfy everybody. And so we have to start picking winners and losers in our AI systems. And so sometimes that means we are going to face hard ethical choices. We aren't, as people who build AI systems, always going to be able to build something that benefits everybody. Perhaps, to go back to the example of the system we're building to predict blood pressure crashes in surgical episodes, perhaps we're able to do it for people who are over the age of 50, but not people who are under the age of 50, or we're not able to have equal performance. And so the system is not benefiting everybody equally. And we have to ask ourselves, is that actually still ethical to develop and deploy such a system when some are going to benefit more than others? And now you might think, okay, that's fine, but that's not the business of us as AI developers, right? This is sort of the parallel objection to the AI is just math, is to say, okay, fine, there are value choices, but companies aren't in the business of value choices. Companies, the only thing they should value, or the only thing they do value, is profit. And so when we talk about beneficial AI, that's not something we should bother thinking about, because the only thing that's really going to happen is companies are going to build profitable AI. But this is, I think, also a mistake, because beneficial and profitable are not antonyms. They're not actually contradictory. We can have systems that are profitable, in fact, precisely because they are beneficial. I think a nice example of this, albeit not in the AI space, is to think about the design premium that a company like Apple has been able to charge for a decade. I know that I use plenty of Apple devices. I don't use them because the hardware is better than a non-Apple computer. I don't use them because even the software is necessarily any better, but they are better designed, and in multiple respects. And there's a lot of evidence that the large profits that Apple has made over the last decade are due in many ways to their ability to have better designed systems, where the notion of design here is it helps people do the things they want to do. That is to say, their technology is in many ways beneficial for people, right? So if you can build technology that actually helps people, you can build trust, you can get lock-in in the customer base, and do all these other things that can enable a lot of profitability. So the argument that I'm trying to make here, at least at the initially, is that when we think about beneficial AI, we shouldn't just think about this as sort of the business of ethicists, that, there's a bunch of computer scientists who are going to build AI systems, and then there's going to be the ethicists who say, yes, but is it beneficial? Rather, we need to think about this as something that everybody is engaged in, is thinking, how do we get systems that actually help people? And moreover, we should do this not just because it is the right thing to do, but also because it can be the right thing for the business or for the developer, or, in general, we shouldn't think of beneficial AI as requiring a sacrifice that somehow, I sometimes will joke that when I'm wearing my hat as an ethicist, it's like, I'm not the fun police. I'm not here to tell people they can't build things. I'm trying to help people build things that actually help and thereby provide benefit to all. Okay, so I wanted to start with these remarks just because I think it's helpful to clarify some issues that sometimes come up when we use language like beneficial AI or responsible or trustworthy AI, is we need to recognize that in some sense, these aren't calling for something more than we should have been aiming for in the first place. Now you might say, well, but suppose you believe me, then you might naturally say, but then, okay, why haven't we done it so far? What are the kinds of barriers that arise to doing this? And in many cases, the barriers are barriers of ignorance on the part of, many cases, the developers. So Amazon, many of us probably have used their services and products, but Amazon gets an enormous number of resumes. They developed a resume screening system that could help to select the people who applied for jobs who are most likely to be suitable and most likely worth an interview. So they weren't hiring on the basis of the AI system, but they were using it to screen resumes. And what they found is that resumes that indicated that somebody was a female applicant tended to be downweighted, that they were less likely to actually receive an interview than a comparable resume from a male applicant. Now, there's a lot of reasons why. Some of them are complicated technical ones. Some of them are because of past historical practices at Amazon at the time they were building this system. But importantly, it's not because the developers at Amazon set out to build a sexist resume screening system. They didn't set out to do that. It wasn't their goal to build a system that would be discriminatory against women. Nonetheless, they managed to do that, right? So that's an example of the ways in which even people who are not intending to build a harmful system or harmful to many may nonetheless do so. So there's been a lot of work that people have been doing over the last, let's call it about 8 years, I would say, really trying to come up with better methods to build and produce and use beneficial or trustworthy AI. So I think these can largely be grouped into about 4 different categories. And I'll go into each of them because I think it's useful to see why some of them have worked and some of them haven't. We've been trying all 4 of these and we've made some progress. We've had some success, but importantly, we aren't there yet. We don't have a set of best practices for beneficial AI that we can simply roll out across the industry or across our education. As when I'm teaching data science undergrads or grad students, I don't necessarily have clear best practices that I convey, even if we do know a lot of the things that people should be doing. So the first place that we all started as a community is looking at trying to use principles, ethical principles, to produce beneficial AI. So every company now, every major company has ethical AI principles. Google was one of the first because basically there was an employee revolt and they said, okay, I guess we need to make sure that we have ethical principles. The government has these. I mentioned EO 13960 about trustworthy AI. In fact, one of the very first organizations of any size to adopt ethical AI principles was the US Department of Defense, which surprises a lot of people to hear. But they were very early adopters of the idea that we should have ethical principles that guide what we do in the development and deployment of AI systems. In fact, it's gotten to the point that now you have like meta work happening, so people doing research about what are the principles that should guide the development of ethical AI principles, and what are the principles that underlie all of the sets of principles. I stopped trying to keep track of it when I got to 150 organizations, each of which has their own set of ethical AI principles. There are similarities between a lot of them, but it reached the point where it's clear everybody was doing it, but there wasn't necessarily coalescing around a single set of principles. Now, the problem is that it turns out these principles have almost no impact on the practice. You can look at, say, the Google AI principles. I often will ask students to imagine themselves to be a Google engineer. So many of the CSE students want to be Google engineers. It's not hard to get them to do that. And you say, okay, imagine that you're working on a project and somebody hands these principles to you. What are you going to do differently? And they basically can't figure out what they should do differently because the principles are written at the level of, don't treat people differently. Okay, what am I supposed to do with that? Or one of the DoD principles is that systems should be governable, which is to say, humans should be able to exert some control. Okay, when should we be able to exert control? How? What are the things that should be possible? None of that is spelled out in any of the principles. So what ends up happening is we have these principles that, in some sense, because they're supposed to apply everywhere, they end up sort of applying nowhere because they don't take into account the particular situations and contexts in which we're building an AI system. It matters if I'm trying to predict blood pressure crash during surgery versus not during surgery. It's going to be a very different set of considerations that I'll have to incorporate into my AI system. And yet the principles don't provide for that because they're trying to be context insensitive. It means they also end up becoming very team sensitive. So some people looked at, in particular, Microsoft to see the ways that different teams were interpreting these particular principles and found very large variation, even within the same company, in how people are interpreting the various principles that are being proposed or are being advocated within that company. And moreover, it's not just sensitive within a team, it's also sensitive to which companies are developing those. One of the features of the modern AI ecosystem is that almost all significant AI systems are built in a distributed way. They almost all involve multiple companies, multiple data sources. It's very rare now to have one company goes out, collects the data, processes the data, builds the model, deploys the model, sells it to customers. We don't see any more single companies that are doing everything. And so now we have to worry about the possibility that I'm a company, I have my own set of ethical AI principles. I want to use Microsoft's Azure platform. It's a platform for doing AI on their cloud system. But Microsoft's Azure, it is designed for Microsoft's AI principles, which are not the same as my AI principles. So now I have to worry, well, is what I'm going to do on Azure actually going to satisfy what I care about, or is it going to satisfy what Microsoft cares about? So we quickly have run into a world where people, I think, recognize that principles are good aspirational goals for guiding the kinds of things that matter when we're trying to build beneficial or responsible AI, but they're not going to be the end of the story. They're not enough. They were a nice starting point, but we don't see a whole lot of talk anymore about this as a way to move forward. I think it's notable, for example, that right now, all the talk of regulation of AI in DC, nobody's asking what are the principles we should be imposing. They're asking for very specific things. And one of the things that people have talked about is the idea that maybe what we need to do is we need to use specialized algorithms. Maybe we need to make sure that our AI systems are only of a particular type. And so one common approach to this is to say what we need to do is we need to simply build our values into the algorithms themselves. Some of you may remember, for example, a lot of discussion about 5 years ago about what's called the trolley problem. This is an old philosophical thought experiment that was misused, I would argue, but to think about self-driving cars, the idea being that a self-driving car might be in a position where it has to figure out whether to crash itself into, say, a telephone pole, thereby harming the occupants of the car, or to strike a pedestrian, thereby harming the pedestrian. And the question is, how should the self-driving car decide? And so there were a lot of calls to have, a utilitarian or a Kantian algorithm that would be implemented in the car, that it would do the ethical reasoning. The same argument was made for autonomous weapon systems. So these are the kinds of things that are being deployed right now by Russia and Ukraine, and potentially by Ukraine against Russia, where you have, for example, drones that autonomously decide who or what to target. So you simply launch the drone, say, go find something like this and blow yourself up there, and the system does it with no human oversight or intervention. And these are systems that at least should, in theory, care about things like, am I detonating right next to a hospital? And so how do you have an algorithm that makes this kind of calculation? The central problem, though, is that actually translating values into algorithms turns out to be remarkably difficult. And moreover, AI systems don't actually understand the world in the way we do. So if we think about self-driving cars, they don't represent the world as consisting of pedestrians and telephone poles and occupants of cars. That's not the way these systems represent the world. They represent the world in terms of areas of space they're not allowed to go into. And some of those areas of space move slowly. We would call those pedestrians, but the system doesn't think of it that way. Some of them move faster. Those we might call bicyclists, but they don't think of it that way. They're just regions they're not allowed to go to. So the kind of algorithms that people want to build, you literally can't build them in a self-driving car because it doesn't represent the world in the way that is required for that algorithm. And so we've sort of moved quickly beyond that. There was a flash in the pan where there was sort of this idea that we could just build ethics straight into our algorithms, that they could do moral reasoning the way we humans do. And that's quickly faded because we humans don't even know how we do a lot of our own moral reasoning, let alone be able to implement it in systems that represent the world very differently. So instead, where we pivoted, sort of the third phase of this all, and this is the phase that I think actually right now a lot of the folks in DC are thinking about these systems, is to say, okay, maybe what we should do is not worry about how the AI system decides what to do. We should just worry about what does it do. We should just try to test the systems. We should audit the systems. We should say what, for example, the Equal Employment Opportunity Commission has said to companies. Now, the EEOC is the regulatory agency that looks for discrimination in hiring, workplace discrimination of that sort. And the EEOC came out with a letter last December from the General Counsel, essentially saying, we don't care if you use AI or not. We're going to hold you to the same standard, which is, do you have disparate impacts in terms of the selections that you are making from your applicant pools? And you can use AI to make those selections. You can use humans. We, the EEOC, don't care. We're going to judge you by your behavior. And that is going to be what triggers an investigation, is your behavior, not whether you happen to use AI or not. And so that's a way of sort of sidestepping a lot of these debates to say what matters for beneficial AI is just, does the system actually benefit people? And that's just about the behavior. It's not about how the behavior is achieved. And so there's a whole lot of different work that has come out proposing audits, proposing ways of doing test and evaluation. New York City, now actually on the hiring front, New York City has a law that requires audits of any algorithm being used in hiring decision-making. And we're seeing the growth of a whole lot of test beds. NIST, the National Institute for Standards and Technology, the part of the government that actually has been doing a lot of the work around regulation of AI and how we might monitor and evaluate AI systems. They're developing a test bed right now for testing and evaluating AI systems. So the idea is that there'd be a kind of sandbox, that if I've got a new AI system, what I do is I can go to their sandbox and I can find out how it's going to work. And I can do it in structured ways. Not sure if somebody is unmuted, perhaps. Now, the problem is that for the most part, these are much like principles. It's not a bad idea, but it doesn't work as well as we would hope. So one of the things that is really valuable about AI systems is that they're able to generalize. They're able to function outside of just the conditions for which they were built or trained. And so the problem now becomes that what we have to do is find a way to test and evaluate outside of the systems in which the context in which we originally trained the systems. How do we pick those contexts? How do we specify that? That often can be a lot harder than we would want. And so this kind of approach of test and evaluation really works best when we have what are sometimes referred to as closed worlds. The classic example of a closed world would be something like a board game. So chess is a classic closed world because I can tell you everything you need to know about a chess game by just telling you the location of pieces on the board. There's literally nothing else that I need to tell you in order for you to know everything there's to know about a particular chess game. Just telling you the location of the pieces and whose move is next. You don't need to know if the pieces are plastic or wood, or even if they're real. Maybe it's all happening in people's minds. And if we have a closed world, then we know what counts as success, usually, in that world. And so we can specify a test and evaluation suite for that. The real world is, of course, not closed. It's more like playing a game of chess, but where the other person can simply change the rules, or where it matters if the pieces are made out of plastic or wood or lots of other things. And so when we think about test and evaluation, we have to be able to specify all of these different dimensions of variation, which turns out to be incredibly hard to do. Moreover, test and evaluation requires us to set a standard for what behavior is the right behavior. But what if we have different groups that have radically different values or preferences? So I earlier mentioned, as a case of value conflict, the case of loan approvals. Well, it turns out that if we just think about, for example, which is worse, a false positive, which kind of, I'm asking here, which kind of error is worse, which kind of mistake is worse? A false positive, that is to say, giving somebody a loan when they can't repay it. So it's a positive, I gave them a loan, but it's false, they can't repay it. Or a false negative, which is to say, not giving somebody a loan, even though they could repay it. Now, it turns out that, and I can go into the details if people want, it turns out from the point of view of the bank, they want to minimize the number of false negatives, which might surprise some of you. Well, banks actually don't worry too much about giving somebody credit who can't repay. Because they're going to get their, basically they'll be able to get most of the money back, or they'll get back enough of it, and they're getting the interest along the way. So banks actually, what they don't want to do is miss out on the opportunity to get lots of interest payments from somebody. Anybody who's bought a house in the last 10 years or refinanced a house has undoubtedly seen that paperwork that shows you how, in many cases, you pay more in interest than you're paying actually for the principal of the house. And so their worry is that they're missing out on all those extra payments. From the point of view of the loan applicant, a false positive is a disaster, because that's the route to bankruptcy. False negatives are actually not that big of a deal, because usually you can just go to another lender and they'll give you the funds if you really are creditworthy. Right? So in practice, what we have is we have two different groups, the banks and the loan applicants, who have completely opposite preferences about whether we should have more false positives or more false negatives. Right? If we're going to make a certain number of mistakes, we know this. Which kind of mistake should we be prioritizing and making sure we don't want to make that mistake? The two groups disagree. So what's the test and evaluation suite for that? There is nothing that everyone can agree on, because there is no single answer for what the good behavior is. Now, there are obvious solutions to this. There are ways around these kinds of problems, but it means that the calls for audit, one of the things we've come to realize is this is always audit or evaluation from a particular perspective. And so that raises real challenges if we want to do things like regulation. There's also a risk of what is referred to as Goodhart's law. You all are familiar with this in the form of teaching to the test, or the fact that standardized testing is not a very good measure anymore. The SAT used to be a good measure of first-year performance in college. It no longer is. And in general, Goodhart's law says anything that is a good measure, if you make decisions on that basis, it will cease to become a good measure. Basically, the idea is that if you're using something to figure out how to allocate a benefit, people are going to find ways to cheat the test so that they can get access to the benefit, even though they don't really need it. Okay, so that's the notion of Goodhart's law. Again, if I tell you what the test and evaluation suite is, you're going to figure out how to pass that, but that might not get us to where we actually want. Some of you may remember about, I guess now, goodness, 10 years ago probably, Volkswagen got in a lot of trouble because their cars were passing smog tests because the car would detect, oh, a smog test is happening, and it would completely change its performance just to pass the test, right? And the worry is that we'd have the exact same thing. We know, for example, that Tesla, it's the range ratings that that are given for it by the EPA and other government agencies, we know are incorrect, because we know that Tesla cars can detect when they are being driven in a way that is similar to the kinds of range tests that are conducted. And it changes its behavior when it's in one of those tests, right? Again, not what we want our AI systems to be doing. So what can we do instead? What we can do instead, where we've moved to now, is the idea that what we really should do is focus on practice. That we need to worry about, how do we train people to function in interdisciplinary teams? How do we build the collaborative skills that are needed for people to, for example, both, have teams that have both computer scientists and sociologists? How do we change the processes by which we develop these systems? How do we have things like data sheets or model cards, or a project that I was involved in where we built something referred to as an ethical triage tool? It's essentially, how do you help data scientists or AI developers know when their project potentially poses ethical risks? It doesn't help them solve those ethical challenges, but it helps them identify what those challenges are, so that they aren't just sort of blindly, perhaps even willfully blindly, moving forward in ignorance of potential ethical challenges. We need to think about things like regulation and industry standards, where industry standards provide a kind of soft regulatory or soft governance approach. We need to think about the organizational incentives. Right now, for example, people at Meta, at Facebook, are not rewarded because they develop systems that actually are informative for people. They're rewarded if they can increase engagement metrics, clicks, and time spent on the platform. And so that's an organizational incentive that's distorting the AI system so that they are beneficial only for the company rather than being beneficial for the users. And thinking about partnerships, thinking about how do we work collectively to achieve it. Now, this might look sort of dry. I mean, it's a long laundry list of different things, which is unfortunately, I think, where we are right. I mean, maybe fortunately, but it's where we are right now as a community, is I think a real recognition that achieving beneficial AI is not about some silver bullet. It's not if we just use this one AI framework, then magically everything's going to work out. What we've come to realize, I think, as a community, is that beneficial AI is going to require a lot of the not so glamorous work. It's going to require that in every AI class, we start talking about these kinds of issues. Even if we're mostly talking about the math, we also need to talk about the impacts on people. We need to talk about, how do you find out what people's values are, or whether there might be a value conflict. We need to be thinking about regulation across many different settings. We shouldn't just pin our hopes on there being a department of AI that somehow is going to magically be able to regulate everything that's out there in perpetuity. And so, I think this has the virtue of being something that it is an approach that enables us to look at the entire pipeline, the entire life cycle of a project. It has the downside that it requires hard work. It isn't just as simple as come up with a set of principles and magically everything works. It also is the only one of these four approaches that has actually been shown to lead to improvements. That most of the things that have been done on the bullets on this slide, people follow that up with empirical studies where they show that, in fact, you do get AI systems that are better designed or more beneficial towards more people or fewer harms, right? So we do have good empirical evidence that these kinds of approaches are going to lead to better AI systems. The problem is that it's not necessarily the kind of work that gets you on, the cover of a magazine, or gets you, invited, say, to Congress where they want to have the magic solution. And I think what this points to more generally is the challenge of doing this kind of translational ethics work. So the idea is behind this is, if we think about translational medicine, there's a long history of the idea that we have to do research in order to apply sort of the lab biomedical work into clinical practice. That is itself a kind of research, is to do that translation. And it's, to use Baddeley's way of putting it, it requires both applied basic and basic applied research, right? So we can't just think of this. It isn't just, oh, that's the application part. It really does require a new way of thinking to do translational work in medicine. And the same thing I think we've come to see is probably going to be true in the case of ethical or beneficial AI systems, that we really have to do substantive research to figure out how to translate our values and our ethical commitments into practice, into things that result in AI systems. And so that's going to involve, both applied basic work, right? How do we take the work that's being done at the Data Science Institute at UCSD? How do we take the work being done in sociologists who are looking at the ways that algorithms and AI are reshaping communities? How do we take that basic research and convert it into practices that we can use? And equally, how can we sort of do the fundamental research on the practices and applications themselves? So how do we look at the use of practice in the wild, as it were? And so in that sense, I think what we're starting to see is the opening of, at least I hope, the opening of a whole new kind of approach to thinking about AI ethics, which is, how do we have both the basic applied and the applied basic research that can get us to a set of practices, governance systems, and partnerships that are going to enable us to have at least more intentional decisions about AI being beneficial for particular groups, and hopefully more broadly, generally. So with that, I'll say thanks, and I've left, I think, half an hour, unless I mistimed things, for Q&A, in case anyone has any questions, which I'm sure people do.
Wonderful, David. Thank you so much for that stimulating and enlightening presentation. For questions, people can put the question in the chat at the bottom of the screen, or can raise your hand using the reactions button, and then I'll be happy to call on you. I'll start it off while people are thinking about their questions. So, David, what do you discuss in your in the National Artificial Intelligence Advisory Committee?
So that, which I'll refer to as NIAC, that's how we refer to it, the acronym. So the NIAC is a federal advisory committee. We are tasked with advising the White House and President Biden on what should be done in the executive branch around AI, broadly understood. So that's everything from, so we discuss everything from what kinds of regulation are needed, to what the executive branch could do on its own, to what they should go to Congress and try to achieve. So, for example, we just actually yesterday had a public meeting of the NIAC, where one of the things we were discussing is essentially what are the things that the federal government should be worried about when it comes to generative AI systems? So these are things like ChatGPT, GPT-4, but also the image generators like Midjourney. And we were trying, we were having an open discussion about what are the risks, but also the opportunities that arise for the federal government with the rise of generative AI systems. Or, how should the FBI be thinking about the uses of AI by themselves and by criminals whom they're attempting to catch? So in that sense, we act as advisors and recommenders to the federal government on pretty much all things AI. It's a really fascinating group to be a part of, and has provided a window into a whole set of issues that I had never thought I was going to have to learn about.
Wonderful, thank you. We have a question by Gil Williamson from Computer Science, I think.
Yes. Can you hear me?
Yep.
Okay, so this is the best talk I've heard on AI by far, but you, like the others, are making a very tragic mistake here, mathematically at the most simple level, and that is to not define in set theoretic terms, neutral set theoretic terms, all of these terms you're working. I've been doing it as like you go along, but too many of them flopped by. You need to define is a relationship, but in a certain set. The AI algorithms, the relationship between a certain set and another set, the domain, the codomain, what is the images, what are the principles of these things? They're all parts of basic logic. And it's such a crushing thing to miss this out. You need to get one of the logicians in your group to just go through and start this off, and it has to be running parallel all the time to all these applications you've been describing. And it's not a criticism of them, but I think it's easy to do, not completely easy, but give you very good insights into what might be fundamentally wrong with the AI process, independent of where its application is going.
So Gil, you are a man after my own heart. So my original training actually was in logic, and so I am fully on board with the value of formalizing in various logical or formal model frameworks to have clarity about exactly what we're doing. In fact, I earlier today was on a call. We're working on a paper which is basically why regulators need to be doing a lot more logic than they are. And it's precisely for the kind of point that you're making, which is that there is a lot of confusion that happens in this space, in part because people are not clear about the use of their terminology, and they don't realize they're using, in many cases, incoherent or just straightforwardly inconsistent terminology. So the utterances that you're looking like, yeah, that actually is inconsistent. There's no way to assign meaning to all the terms in a coherent way. So I'm totally on board. I didn't necessarily think that a Zoom talk at 4:30 on a Wednesday that people wanted to see a whole lot of set theoretic notation. But actually, most of the things that I've been discussing, you can mostly formalize in set theoretic notation in useful ways to cash out what we mean by relation and so forth. Unfortunately, it's not universal. You can't get everything. And part of that is because we are inevitably dealing with some relatively vague terms. So a term like safety, I can make it precise, but only by giving up on some of what we mean in ordinary language by the term. So I do think there are some limits, but I think it's an incredibly valuable tool that I agree with you is underutilized in AI and even in people looking at the impacts and regulation of AI.
Janet Smar, you have a question? And please identify your department.
Hi, yeah, I'm from the Department of, retired obviously, Department of Theater and Dance.
Wonderful.
So, and I'm aware of the part of the actors' strike has to do with the use of AI that is based on their bodies and on their work, but then not paying them. There's been a lot of discussion about the data sets on which AI is trained and what is acceptable and not acceptable. People who don't like their work being scraped to create images in their style and so on. I wonder if you could address some of that.
Sure. Happy to dive into that. And I think what you're raising or pointing towards, I think, are the two big issues that often come up. One is we can think of as on the input side, which is the data that are scraped to train the AI systems. And then on the output side, how do we think about what's coming out of a lot of these generative AI systems? So a lot of the writer's strike is about worries that the output is going to be used to replace them or otherwise deprive them of the opportunity to make a living. And so in that sense, what we're, I think you really put your finger on the two big issues there. I'm not a lawyer, so please recognize that in what I'm about to say. I think on the input side, there currently are multiple lawsuits against these companies like OpenAI, Anthropic, Google, basically claiming that the copyrighted material was used without permission in ways that violates copyright law. OpenAI says, no, it's fair use. You put it out on the web, we're allowed to scrape it. You should have, taken it down if you didn't want it to be looked at. But they would argue that it's no different from a musician who listens to a lot of different songs and then generates something that, of course, bears echoes of things that they've heard, but is fundamentally new. I think my own personal view, again, not speaking as a lawyer, but speaking ethically, I think that that's a disingenuous argument by the companies. I think that when we look at what it is that something like GPT-4 or on the image generation side, DALL-E or Midjourney, when we look at how that technology works, I think it is disingenuous to say it is a remix of a bunch of different things that the system has previously seen or read. I think what we're looking at much more is systems that are identifying rich statistical patterns across all of the corpus or images that are put up on the web, and then is extracting those patterns. And that's very different from what humans do, which is a much more, at least my view of it when you look at the actual cognitive science, is that humans are much more synthetic as we view a bunch of images. You can show me 27 images and what I'm going to remember is some composite or synthesis, not necessarily each of the 27 individually. So the very way the technology works, it seems to me, is not fitting with the traditional ways that we've thought about people being inspired by previous art. So my own view is that there is something deeply problematic from an ethical perspective about the way these systems were trained. And as a result, I think that there are real problems with a lot of the output. I think the claims of novelty, the claims that OpenAI owns the outputs of these systems are at least ethically problematic. Again, I can't speak to the legal issues, but in part because everybody I know who is a lawyer that I've asked about this says, yeah, this is unbelievably hard and the law is just not written for this kind of case. And so I think you've put your finger, though, on a critical issue that we're all wrestling with. I mean, one of the things I'll just say one last comment. So many of these things have really only come into the public consciousness since ChatGPT. And ChatGPT, I would just remind everybody, was publicly released less than 10 months ago. Like it isn't as though it's been out there for 10 years. And so we as folks who work on this are still trying to wrap our heads around how to think through some of these issues.
Thank you. In the chat, we have a question from Paul. I hear a lot in the media dealing with AI being used in the educational setting by students to facilitate the creation of term papers. Do you know if there is any effort at educational institutions at all levels, including UCSD, to try to help identify and combat such tactics by students?
Yes. Yes, absolutely. There's a lot happening. It is probably the topic of conversation that comes up the most when you get a group of faculty together on campus these days. In practice, it turns out the identification turns out to be just really difficult to do. There are systems that will claim to be very accurate at identifying text generated by GPT-4. they turn out to not be very good. When sort of as soon as you tell that somebody who's generating the text that it's going to be put through one of these detectors, they can make very small changes that defeat it. I mean, it's not like a plagiarism detector where it can do pretty well even when the student tries to change this word or change that word. Small changes actually defeat the AI detectors. So on the detection side, I think that is a losing battle. So where the challenges come up on the educational side, I think is right now, my view is my read on the way people are approaching is there's really kind of two camps. There are the people who say we need to combat this, we need to stop students from using these systems. And there, a lot of it is students now have to do a lot of rewrites, or you make them submit things all along the way. So you have to submit your outline, and then you have to submit drafts, and then you get feedback, and you have to correct the drafts. One of the problems, of course, is that GPT-4 is perfectly capable of generating an outline. It's perfectly capable of doing rewrites when you ask it to. So it isn't necessarily going to be a path forward, but it's a thing people are trying. The other approach is the other camp, I should say, are basically people who are not trying to stop students from using these tactics directly. So here you have people who, one of our colleagues at UCSD, Stuart Geiger, he actually uses it in his teaching. So he says to the students, you have to go generate text using GPT-4, and then they build off of it, and they have assignments where they have to look at and analyze what it is that the system has produced. Some of my colleagues in philosophy at other universities are doing things where students use these systems to generate text, and then the student's job is to write a paper that says what's good or bad about the argument that was generated, right? Or they have to generate they use it to generate a summary of late Wittgenstein's thought, and then the students have to critique whether that is an accurate or inaccurate summary, right? Alternately, you can think about sort of embracing the technologies by saying, this means I have to rethink the assignments I give. So one of the things it turns out with these generative AI systems is that because they look at everything that's on the web in some sense, they're really bad at specifics, and they're really bad at hypotheticals, like any hypotheticals with any specificity. So if you ask them a hypothetical question, right, if I did this, what would happen? The systems very quickly go to high-level generalities. Or an assignment that I gave to some students last winter quarter was I said, go and read the terms and conditions for a social networking site that you use. Twitter, Facebook, well, none of them are on Facebook, Twitter, Be Real, Instagram, and basically said, actually read the terms and conditions, find out what data are collected about you and how it could be used. And part of the reason I was willing to give them that assignment is because I gave that assignment to GPT-4, and it did terribly. It just gave, here are the kinds of things that appear in terms and conditions. There was none of the specificity that somebody who actually did the assignment was going to do. So if we move towards assignments that are more based, this is now my personal view, if you move towards assignments that are more based on creative thinking, on critical analysis, on specifics for hypothetical or counterfactual questions, right now, generative AI systems are not very good at that. And so if a student wants to do it, that's fine, but they're not going to get a good grade on the assignment. Now, it's not a long-term solution. GPT-5 is going to be better than GPT-4 at these kinds of things, right? So, but it is something that everybody is scrambling to worry about, and we'll see where we land.
Okay, wonderful. Steve Rose has raised his hand, has a question.
Yeah, thank you very much, Barbara, and congratulations, Dr. Dane, on a very eloquent presentation. Well done. My question, Dr. Dane, is if you could comment perhaps or embellish on the overlapping areas of AI and robotics.
Yeah, I wasn't sure if there was if you want me to talk in a specific area or just sort of more generally.
Well, my personal area I'm from the Department of Radiology as an interventional radiologist. My personal interest would be in performance areas in medicine, surgery, and image-guided surgery like ours is. But in general as well would be interesting probably to more of the folks in the audience.
Yeah, so I shouldn't say our colleagues in mechanical engineering might be annoyed by what I'm about to say, but in many ways, the physical control of a robotic system, I don't want to say it's a solved problem, but it is truly a kind of straightforward engineering thing for most use cases. It is the intelligent control of a robotic system that is where most of the work remains to be done. And that is at heart a kind of AI problem, right? So it's about the brain part of it, less than about the physical manifestation of it. So in robotics, one of the things that is, I'll harken back to the reference I made to sort of closed worlds like games, where it's really easy to know what to do. Robotic systems invariably are in the real world, which means they're in open worlds. It means that when you go to do surgery, you don't quite know what's going to happen when you open the person up and you take a look. People are weird and new things will happen along the way. So we're finding robotic systems work really well when you have very controlled or constrained situations. There now are robotic systems that people have shown to be quite good at doing what I would think of as sort of superficial soft tissue work. So suturing closed a clean incision, for example. So we now do have systems, they're not in deployment to the best of my knowledge. We have systems that have been repeatedly tested. So the idea would be that for a fairly simple, you do some laparoscopic surgery that, the fairly small incision, the doctor could simply leave and a robot could do the suturing for that. There have been larger uses of robots for soft tissue surgeries, but only on animals and on cadavers. And so they're very small samples and people say, look, it works great, but we have no idea how it would actually perform in any real world context. And here I think the experience with self-driving cars is actually pretty informative. I mean, they're a kind of robotic system. And self-driving cars, we got to 95+% of human performance about 2014, 2015. We by any measure most people would look at, we got to about 95% of human performance. We're now in 2023, and by most estimates, we're at about 97%. So we got to a certain level, but it's been incredibly slow to get any real advances after we got through the sort of big breakthroughs. It's been the case for a decade now that a self-driving car is going to be safer on an interstate during the day in Texas than a human is, because they can just, they don't fall asleep, they don't get distracted, they aren't texting. It's still the case to this day that if there's a tropical storm that hits San Diego, a self-driving car is going to be a disaster, but a human is still going to be perfectly fine. So we would expect to see the same thing, I think, happen with robotic systems across a wide variety of use cases, is we're going to see these systems get to very good performance pretty quickly, because those will be the standard cases. And then they're going to find we're going to find a lot of difficulties. There's going to be very slow going to get the edge, what we might call the edge cases. And it's going to, how big are the edge cases? How important? Well, it's going to depend a lot on the particular domain we're looking at. But that's, I think, where we're looking at right now with robotic systems. Most of the work in robotics these days is focused on these kinds of edge conditions, the weird things that can happen, but within a recognition that it might be a weird, unusual situation, but if it leads to a fatality, that doesn't matter. We shouldn't have, we need to be careful about that.
Thank you. I'm back to the education comments. I would like to remind everyone that there was an excellent article in the Chronicles edited by Stephen Adler and managing editor Suzanne Jaffe about education, AI, UCSD, and and the different approaches that David outlined regarding faculty members. There was a question in the chat from Alan McCutcheon, but somehow it disappeared. Alan, do you want to ask your question? I see it. Many of us have become more aware of AI issues through the emergence of GPT. Has this change influenced the resources that you and others have to investigate the ethics in the field?
Yes, it has absolutely made a difference. Unfortunately, it's been a negative difference, not a positive one. I think one might have hoped that as these kinds of systems became better known in the public, that this would mean recognition that we need to devote more resources to trying to understand the behavior of the systems. What's actually happened is because these systems have entered the public consciousness so much, all of the companies that build these systems, and right now the vast majority of the cutting edge work is being done, quite frankly, at companies, they've all pulled back and closed their doors. There's one of these things where if we flash back to last November when ChatGPT burst onto the public consciousness, ChatGPT was actually at the time the third best performing of the large language models. DeepMind had one that performed better, and actually Meta at Facebook had one that performed better. But nobody really knew about that because it was sort of known in the community. These were systems that, because of their potential to be really problematic, everybody was keeping them sort of in-house. And so we, as folks who work on things like the ethics of these systems, we were able to talk to the researchers. We could go and find out what's actually going on, and we could help them with what are they doing in the way of, checking for errors and trying to understand the behavior of these systems. OpenAI puts ChatGPT out into the world. Everybody kind of goes wild for it, and it's like, this is absolutely amazing. 100 million users in less than a month. And instantly, all of the other companies completely closed their doors and said, we're not talking anymore. We're just doing everything in-house. And so what's happened has been, because these things are now so much a part of the public consciousness, companies have gotten incredibly cautious. And it's meant that folks like me who want to be able to know what is the cutting edge, what are people working on right now, what are the things we should be getting out ahead of, right? What are the kinds of papers that we need to have ready to go, or the things that we should be warning regulators? Hey, look, there's going to be technology of this kind coming. You need to be prepared, and you need to have thought through what you're going to do when these things emerge. We're not able to do that now. We're not able to do it in the same way. There is still, as often happens in an industry, there's still a kind of whisper network. We all still do know each other, and people will talk if you can, after a workshop, go out and grab a beer. But it's really changed and formalized things in, I think, unhealthy ways. Now everything has to go through legal clearance. And it's made it much harder, I think, to have the kind of open conversation that's needed. The spirit of open scientific inquiry that used to be present in at least the research side of tech companies, in a 12-month span, it's largely disappeared. And it's been a very challenging and frustrating experience.
Thank you, David. I'm going to ask one final question. For the future, what is the future of intelligence, creativity, and being human? Will it be required that we use these AI tools in order to be considered intelligent and creative? Will those individuals who are not using these AI tools be disadvantaged in major ways?
I certainly hope we do not end up in that world, because I think that something important would be lost. But I also think that we need to be willing to ask exactly that question. And we need to ask it with the recognition that technology can make certain things much, much easier and much better. I am of an age that I grew up learning to drive a stick shift car. I have lost some skills like that because of the advances in technology. I don't think I could drive a stick shift car nearly as well anymore. We have demonstrable evidence that people are worse at spelling now than they were 30 years ago. Spell check has made people worse spellers, but it hasn't done so in a way that I feel like we've lost anything intrinsic to our humanity. The fact that people can't spell as well, I don't think that that's really undermined who we are or what makes us worthy of respect in a moral sense, for example. And so I think we need to be willing to have these discussions about what are the capabilities and capacities that we think it's important for humans to maintain, that we think it is an important part of who we are to continue to be skilled at these activities. As people have gotten worse at spell check, they've actually gotten better at writing. We all like to think, wow, students are really terrible at writing now. They are actually, people have shown over and over, student writing now is better than it was 20 years ago. And in part, that is probably because if you've got spell check, you can focus on the idea and you're not quite so worried about it getting the spelling right and these kinds of things. Plane flights are a lot smoother because of autopilot. And so I think we really need to openly discuss and debate what are the things that we think really make us human. When we talk about creativity, what do we mean? Do we mean that it's about generation of new ideas that force people to rethink the world around them? Well, you can use an AI system to facilitate that. You just need to make sure that what you're putting out in the world really does bear your intent. And so those are the kinds of things that I think we as a community, as society, we need to be having these open debates and discussions, and not sort of just stumble into a future that turns out to be a lot worse than any of us wanted.
Wonderful. On that note, I want to thank Dr. Danks for a provocative discussion. I want to thank the attendees for participating. I want to thank the individuals for the excellent questions. And we look forward to seeing all of you next month with our next meeting and lecture series. Thank you.
Thanks so much, everybody.